that the general solution of the differential equation y double prime plus 3y prime minus 18y equals e to the negative 2t was y of t equals negative 1 over 20 e to the negative 2t plus c1 e to the 6t plus c2 e to the negative 3t. And now that we have the general solution of the non-homogeneous differential equation, we can impose the initial conditions to solve for c1 and c2. Using that y of 0 equals 3, we have that y of 0 equals 3 on the left-hand side, while it equals negative 1 over 20 e to the negative 2 times 0, plus c1 e to the 6 times 0, plus c2 e to the negative 3 times 0. And since e to the 0 is 1, this simplifies as negative 1 over 20 plus c1 plus c2. To use the initial condition y prime of 0 equals 5, we need to first compute the derivative y prime of t. Doing this, we get negative 1 over 20 times the derivative of e to the negative 2t, which is negative 2 e to the negative 2t, plus c1, 6 e to the 6t, plus c2 times the derivative of e to the negative 3t, which is negative 3 e to the negative 3t. So we get that y prime of t is negative 1 over 20 times negative 2 e to the negative 2t, plus 6c1 e to the 6t, minus 3c2 e to the negative 3t. Evaluating this at 0, we have on the one hand that y prime of 0 equals 5, while on the other hand, y prime of 0 is negative 1 over 20 times negative 2 e to the negative 2 times 0, plus 6c1 e to the 6 times 0, minus 3c2 e to the negative 3 times 0. And again, using that e to the 0 as 1, this simplifies to 1 over 10 plus 6c1 minus 3c2. So we now have two equations with two unknowns, c1 and c2. From the first equation, we can solve for c1 to get that c1 equals 3 minus 1 over 20 minus c2. And plugging this into our second equation gives 5 equals 1 over 10 plus 6c1 minus 3c2, which can be replaced with 5 equals 1 over 10 plus 6 times 3 minus 1 over 20 minus c2 minus 3c2. And we can solve this for c2 to get 67 over 45, which means that c1 is 3 minus 1 over 20 minus c2, which is 67 over 45, giving c1 equals 281 over 180. So we now know the values of c1 and c2 in our general solution that satisfies our initial conditions.